Hello everyone, in today's video we will be covering our first lesson of Unit 2. Unit 2 is covering all sorts of things about the coordinate plane, looking at some more segments, some angles, distances, midpoints, and a few other things as well. Today we are starting with section 1 called Segment Length and Midpoints. And we're going to start with the Pythagorean Theorem. Now the Pythagorean Theorem is something you all should have seen before. It says that the square of the hypotenuse of a right triangle is equal to the sum of the squares of the other two sides. So I have a squared plus b squared equals c squared. So on this triangle here, this side is a, b, and c. And what they're saying in so many words, if you were to draw a square around each side, you're just going to have to pretend those are squares for me. I know they're rectangles and they're not very rectangular at that either, but pretend they're squares. So you have all these squares, and if you were to find the area of each of these things, then when you put them together like this, area of A plus the area of B is equal to the area of C. And when we square root that C to solve, that gives us this one length. So that's what we're looking at there, almost as if we had these squares around the triangle that we were solving for area. So now we're going to go ahead and just do a review problem. So we have this question here where I have 3 on one side, 4 on my other leg, and then my hypotenuse is 5. So I'm going to go ahead and write that out as 3 squared plus 4 squared equals 5 squared. And if this is a true right triangle, this will be a true statement. So I have 3 squared is 9, 4 squared is 16, and when I add those together, it should equal 5 squared, which is 25. It does, that checks out. 25 is equal to 25. All right, so this is just a review problem, but if we don't have a known side, a little more review for you here. Now we can use the Pythagorean Theorem to solve for our missing side length. And this is going to come in handy when we're looking at our graphs in just a moment. So I have 8 squared and 6 squared for my side lengths, my a squared plus b squared. And that is equal to my unknown length c. So I have this c squared that I'm going to plug in place. 8 squared is 64. 6 squared is 36. We still don't know what c squared is. 64 plus 36 is equal to 100. Is equal to c squared still. I want to get this square out of there. The only way to undo a square is with a square root. So I'm going to take the square root of both sides. On this side, that cancels down to c, and on this side, the square root of 100 is equal to 10. So now I have that c is equal to 10. So my missing side length is 10 centimeters. All right. Let's go ahead and turn the page. Now we have this distance that we're trying to solve for. It says find the distance between the 2 points r, -3, 4, and s at 5, 1. So I'm going to go ahead and start by plotting those 2 points. So I have r at -3, 4, which is right there. That's r. And I have s at 5, 1, which is right there. Over 5, up 1 is s, and that is a segment that I'm trying to find the distance there, so I'm going to draw a line connecting those 2 points. So now, using the Pythagorean Theorem, I can solve for this side length. So I'm going to start by finding my unknown legs, and this is going to be my hypotenuse. So I have, I'm going to draw a dotted line. I went down that many, over this many, and that creates our triangle. There's 1, 2, 3 on that side, and 1, 2, 3, 4, 5, 6, 7, 8 on the bottom. And I'm counting whole squares. I'm not counting lines. I'm counting the squares that we covered. So now I'm going to go ahead and say 3 squared plus 8 squared is going to equal my segment RS. So I have this segment. Remember, when we are naming a segment, we draw just the segment with no arrows on the end. So it's the 2 points with no arrows in the bar. 3 squared is equal to 9. 8 squared is equal to 64. And we still don't know what RS is, but when we add those two things together, it will give me my length. So I have RS is equal to 64 plus 9 is equal to 73. And that would be units. We don't have a given unit for that. All right, so this is one method we can use, but there's another way to solve for the distance between 2 points without having to draw a triangle and find the triangle side lengths. We can use what we call the distance formula. This is the distance formula here. It says D is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. So we can solve just using the points. We don't have to draw a picture, we don't have to plot the points. We can just plug the points into this equation and solve. So we could go back and solve for that same problem using this distance formula, but we're going to go ahead and do this example with just the points, and you could do the exact same thing for the other example. So I have my x1, y1, those are going to come from the same coordinate point. So I'm going to call this 4, 5, x1, y1, and 8, 7 will be my x2 and my y2. All right. So I have set 1, set 2. Now I'm going to take those and I'm going to plug them into this formula. So I have D is equal to the square root of all of these things. So I have my x1, which I said was 4, minus my x2, which I said was 8, squared, plus my y1, which was 5, minus my y2, which is 7, and that's squared as well. So now I'm going to start by simplifying what's underneath the square root. So I have the square root of 4 minus 8 is equal to negative 4, so I have negative 4 squared plus 5 minus 7 is equal to negative 3, so I have negative 3 squared. If it helps you to put parentheses so you don't forget that the negative is being squared, please do. All right, so now I'm going to simplify that one more time. Negative 4 squared is the same as positive 4 squared. So this is a 4 times 4, which is equal to 16. And negative 3 squared is the same as positive 3 squared. 3 squared is equal to 9, which is equal to the square root of 9 plus 16, which is 25. The square root of 25 is equal to 5. So I know that my distance is equal to 5. And this is the amount of work that I should see on your papers. Every now and then, there are some lines that are easier to simplify, and if that's the case, then I'm okay with you skipping a couple lines. For example, skipping from here to here is all right, or here to there, but you should have at least 3 lines. All right, now that we've done this example, we're going to go ahead and look at midpoints. So I'm going to switch to the next page, and then just for some review, we have this segment here. It says, what is the midpoint for the line segment shown here? So I'm going to go ahead and start by going from each point. I'm going to work in together until I get to the middle. I'm somewhere between 0 and 1, but it's the midpoint, so I'm exactly between 0 and 1. So I'm looking at this point right there, which I will draw on real quick. And this point, exactly halfway between 0 and 1, is 0.5. So that's one method, but our lines are not always going to be on this nice number line where it's easy to just go and connect from 1 and go right into the middle. Sometimes your line is going to be on a graph, like this problem here. So we're going to go ahead and start by plotting these points 3, 2, and 5, 6 on this coordinate plane, and then we're going to use some of our knowledge to find the midpoint. So I have 3 over 3 up 2. And I have over 5 up 6. Those are my points, and I'm looking for the midpoint between these 2 points. All right, so we drew the line with endpoints, and now we want to find the point that's exactly in the middle of the line. So there's a couple ways that we can do this. We can start by thinking of it like a triangle, and I went over 2, so my point should be going over 1 because half of 2 is 1. And I went up 1, 2, 3, 4. So if I traveled 4, then I should be going halfway, so 2. So I'm over 1, up 2. So this point right on the line, right there, that should be my midpoint, which I'm going to call N for midpoint. All right, so that's one method. And this one method works. You also might have been able to look at this and say, oh, well, that's pretty easy. That's a small line, it crosses right over. But what if the line isn't so easy? And what if I only gave you these points and I didn't have a graph for you to graph them on? Well, that's when we use something called the midpoint formula. So the midpoint formula, N, the midpoint is N, of a line from P1 at, so point 1 at x1, y1 to point 2 at x2, y2 is found by M is equal to x1 plus x2 over 2, y1 plus y2 over 2. So we're adding our x coordinates together and dividing by 2, and we're adding our y coordinates together and dividing by 2. So the example above, we had these points 3, 2, so I'm going to call this x1, y1, was at the point 3, 2, and my y, or x2, y2, was at the point 5, 6. So now I take these points and I'm going to plug them into this formula. So I have M is equal to, in my formula, starting with my x's, x1 plus x2. So I have 3 plus 5 divided by 2. And my second point will be my y's added together divided by 2. So I have y1 plus y2. 2 plus 6 divided by 2. So this is equal to, as I'm simplifying, 3 plus 5 is 8. So I have 8 over 2. And 2 plus 6 is also 8. 8 over 2. So M is then equal to, simplifying it down all the way, 8 divided by 2 is 4. So this is at the point 4, 4. And if we go back and we look at our graph, we should notice that the point that we previously pointed out is at that coordinate, which is right here, over 4, up 4. That point M is our midpoint. Right here on the next page, we've got a couple more examples before we start working on our whisks and our practice questions and the other pieces that come with our lesson. So this example here says to find the midpoint of the line segment with endpoints at -2, -1, and 4, 7. Make sure to draw the line segment and include the endpoints in the midpoint. Okay, so I'm going to start by plotting those points on this graph. So I have -2, -1, to the left 2, down 1, 4, 7, to the right 4, and up 7. That is my line segment, and those are the endpoints right there. And now I'm trying to find the midpoint of these 2 points. Now you could go ahead and try to find it on there. This one doesn't look like it's as easy to work with, so I want to use my midpoint formula anyway. So I have M is equal to my x1 plus y1, and it doesn't really matter which one you determine to be x1 and x1, y1, and x2, y2, as long as you pick one and you stick with it for the whole problem. So I'm just going to go ahead and start with the first one because it came first, but again, you could switch them up if you wanted to. And then my x2, y2 will be the second point. So I have -2 plus 4 divided by 2, and I have -1 plus 7 divided by 2. -2 plus 4 is equal to 2, so I have 2 over 2. And then I have -1 plus 7, which is equal to 6 over 2. So that means my midpoint is at the point 2 divided by 2 is 1, 6 divided by 2 is 3. So my midpoint is at the point 1, 3. And if you didn't use a ruler, then your point might not be exactly on the line like mine isn't. As long as it's very close, then that is fine. All right, our last example today. We have M is the midpoint of xy. If x is at the point 2, 6 and M is at the point 1, 2, find the coordinates of y. Okay, so let's break that down here a second. It says that M is the midpoint of xy. So I'm going to draw a picture here. So I have this segment that is going from x to y, and I know that the middle of that is point M. And I know my x is at the point 2, 6, and my M is at the point 1, 2, but my y is the one that's unknown. So we're not solving for the midpoint this time. This time we're solving for one of the endpoints. So how you want to think of that? Our midpoint, M, was represented by points before, but this time we know it. So we have this point 1, 2, and that is equal to our formula, which is our x1 plus our unknown x2 divided by 2, and our y1, which we know is 6, plus our unknown y2 divided by 2. So really what's happening here is we have two separate equations. So I have 1 for my x is equal to 2 plus x2 over 2. And I have a separate equation for my y. So I have 2 is equal to 6 plus y2 over 2. So now that I have these two separate equations, now it looks a little bit more like something I can solve. So I'm going to start with my x over here. I want to get x by itself, so I'm going to start by getting rid of this fraction by multiplying both sides by 2. So I have 2 is equal to 2 plus x squared, x2. Now I still need x by itself. I'm going to subtract 2 from both sides, and that means that my second x coordinate is going to be at 0. And now I need to solve for my second y coordinate. So I have another fraction here. I want to get that 2 from the bottom, so I'm going to start by multiplying both sides by 2. So I have 4 is equal to 6 plus my second y coordinate. I want to get this by itself, so I'm going to subtract 6 out from both sides, and that gives me that y2 is equal to -2. So my coordinates for y were found separately, and now I'm going to stick them together. So I have that y is at the point, (0, -2). Those are my y coordinates. I'm going to make sure I box my answer. So I should see, when you're solving a problem like this, I don't have to see this part. I do have to see each individual solving. So I solved for x, I solved for y. These two pieces should always be shown on your work. All right, that is where we're going to wrap it up for today. There weren't too many examples in here, but all of these problems are solved in a very similar way. So if you are not sure about how something like this is solved, please reach out and ask. I'm happy to send a little bit more help, but please make sure that your questions are specific and you're asking about particular questions so that I can have a little bit more direction on how to help you. We'll go ahead and pick back up with our next section on partitioning a segment in our next video lesson.